talk a little bit more about even and odd functions and building on what we did last time. Now let's just suppose that we have a function f of x. Okay. Now to review what we talked about last time, the function f of x is even. Let me draw my x and y axes. F of x is even if the function is symmetric across the y-axis. Okay, here's the y-axis, here's the x-axis. So if the function is symmetric this way across this axis here, then we say the function is even. So for example, y equals x squared equals x squared is an even function because it looks something like this, and it's symmetric across this. If the function is symmetric across across quadrants, in other words, if it's symmetric this way and this way, then we say the function is odd. Okay, remember that? So let's suppose we have any function, and that function f of x is neither even or odd. Suppose I take, okay, so I'm given f of x. Now suppose I take 2 times f of x. And so I can write that as f of x plus f of x. Okay. Now, it's 2 times f of x. Now, suppose I add and subtract f of negative x to both sides. So I'll take 2 times f of x is equal to, now here's what I'm going to do. I'm going to take f of x plus f of x, and now I'm going to take plus f of negative of x, like that, minus f of negative of x. Now, since I've added here and subtracted the same thing, I haven't changed the value of the expression. Now let me rearrange terms. Let's take these 2 terms and put them together, and let's take these 2 terms and put them together. So I'm going to rearrange my terms, and when I do that, I get this is equal to f of x plus f of negative of x and then these 2 terms, the other 2 terms, let me put become f of x minus f of negative of x. So the negative sign goes with that term, and the positive sign goes with this term. Okay? So I've taken the sum of these 4 terms, rearranged them. Let me put parentheses around. So I have parentheses around this and parentheses around this. Now what I want to do is I want to look at these 2 expressions separately. I want to look at this expression and I want to look at this expression. So let's look at f of x plus f of negative of x. So I want to look at f of x plus f of negative of x. Let me call this let me just call it g of x. This should be g of x. Okay? So let me ask the question of you, is g of x itself going to be a positive, is it going to be an even function or an odd function? So in other words, what's the relationship between g of x and g of negative of x? What is that relationship? Okay, now go back over here. Okay, g of x is equal to f of x plus f of negative of x. So everywhere where there's an x, let me replace it by a negative of x, so that this f here becomes f of negative of x plus this negative of x. Now a negative of x becomes a positive of x, and this is g of negative of x, of negative x, negative of x, negative x. So if I take this expression and I replace x by negative x, there, I have f of negative x plus f of positive x equals g of negative x. However, this is exactly the same thing. This is equal to g of x. This was our definition of g of x. So we have that g of x is equal to g of negative x. So this now implies that g of x equals g of negative x. That means our function g of x is even. Okay, g of x is even. Let's look at that other function we had. The other function, which I'll call h of x, was equal to f of x minus f of minus x, or f of negative x. This. Now, what's the relationship between hx and h negative x? In other words, what's this relationship? Well, let's see if we do what we did last time, and everywhere where there's an x, we replace it by negative of x, and then negative of negative x becomes a plus. So this becomes h of negative x is negative f of x equals negative of f of x plus f of negative x. Now, by the definition of h, this is just equal to negative of f of x minus f of minus x. Now, by the definition of h, this is equal to negative h of x. So here's what we have, that h of negative x is equal to negative h of x. This means that h of x is odd. Okay, now let's summarize what we have just shown. we said that